expectations about security. What is secure and when do you know something is secure? And it's been applied to smart cards in general and especially to Java cards. Common criteria exists of 3 big documents describing procedures and terminology for describing security and threats and counteractions and all those things. It also describes how to establish that the product you make are actually meeting the expectations you formulate in that in those description of security. They recognize 7 levels. The lowest level means no security, no statement. The highest level is very few products reach that, and it is very strict, and you have to do a lot of formal proofs about the correctness of your design and your implementation documentation, etc. It's based on independent evaluators, organizations which you pay lots of money to read through the stacks of documentation. It probably is around 1,000 pages for a smart card and documentation that you have to deliver. And it's very expensive. A typical smart card product, and you have to do the whole product from hardware to the software and some of the applications, will cost you over 2 million euros to get it evaluated at a reasonable level. Reasonable levels nowadays for smart cards are 4 and over. There's one smart card product at 7, but I don't know whether anybody's actually using it. But it's cool that someone actually achieved it after 10 years of hard work. All in all, there are 50 products you can buy which have been evaluated to a certain level. EAL means it's a level of assurance, meaning how sure can you be that security has been achieved, and those products meet some criteria. Of course, this is very flexible, so you can write very weak assumptions, very weak requirements, and then be proven to meet those very weak requirements in a very strong manner. But the more you go up, in 4 or 5, there are more requirements to actually be some security. So those products, you have some expectation that it is pretty hard to break in. And like all security, break-in in cars is always possible. You cannot expect that any car system, if you have enough value on it, will remain unbroken. But a particular card, you will not be able to get in very easily. This is then the end of my main part of the talk, and we can go into some conclusions. Smart cards are very widely used to do something with security. Java cards allow you to do something a bit easier, and security is hard and remains a thing to be careful about. Then there's time for some questions. So, please go ahead. There's a question in the back.
Thank you, Eduard, for this presentation. Please, questions?
Thanks. I was wondering, you mentioned that the Java cards have the ability to generate keys. What entropy sources do they use for the random number generators, and is that specified by the Java card standard so that you know when you're writing some code to run in a Java card, you're going to have strong keys generated?
The Java card specifications do not involve any specification about keys or algorithms. Most Java cards nowadays use hardware random number generators of some type. I'm not sure what they use. It may be noise, so you may have an attack on the random number generation by cooling it. But there's hardware number generators. Most countries have standardization bodies that specify cryptographic parameters, like the length of the RSA key that to be used for certain functions. They also specify the quality of random number generators. And most products specified, when they are evaluated, are actually specifying the strength of the random number generator in their security specification. So while the Java card doesn't specify it, all products on the market will meet some government body's expectation of random number quality.
I Well, thank you. If I would like to get some hands-on experience with Java cards, you mentioned that they're not freely available. Can I buy them somewhere on a website, or how does that work?
If you go to a manufacturer's website, Giesecke and de Vrend or Gemalto are the larger ones. You'll be able to buy, they're very expensive relatively, I mean a couple of €100. You will be able to buy a development kit which will come with cards that you can load them onto. The easiest way to work with it is using Eclipse or NetBeans, or there's another framework from University of Michigan where you can actually run the code and emulate it. So the emulation is and they're true complete Java card emulations. So you can actually run it in a true sense, talking APDUs and using the whole stack if you want. But real cards, you have to buy from manufacturers. I don't know any source which builds Java cards which are freely available for use. But there may be. I mean, I haven't looked at it very carefully, so there's a question there.
I saw that there was an AIS implementation. Is it in source, and how fast is it?
Again, Java card has doesn't specify anything. It specifies identifiers and data type to.
Yeah, but I saw you use a library.
Well, the library is provided by the smart card manufacturer, and okay. they either use a software or a hardware implementation, and most have hardware accelerators for AES. Okay. And I don't know. You have to look at the product sheet of each of those chips and see how fast they are.
Okay. And
I mean, you can go to Infineon website and look at the products for smart cards, and they will specify the AES implementation they support. STMicron is the same. So those chip manufacturers will actually have done all the work and make sure that they provide the firmware and the hardware for doing encryption. So I don't have no details.
Is there an open source tool chain to work with Java cards, or do I always have to use some proprietary tool chain or middleware?
There is an open source available. Well, both NetBeans and Eclipse come with modules to work with Java cards, including the emulators of the card level. The moment you want to use real cards, you have to go use a real card loader application, which is embedded in a real card. And that usually comes either with a set of open keys that are public. I mean, they are desk keys, and you know the key, and that's published on the documentation. To get those things, you have to go to the manufacturer. So it's open until you need real hardware cards that you want to work with.
Any more questions? Yes.
Hi. Can you return to the slide where you mentioned some evaluation of security levels, some EAL? Yes, evaluation assurance level. Yes. Can you talk a little bit more about that? I mean, what are the kinds of attack and the countermeasure of that?
So in common criteria, you are required to produce several documentation on any product you make. One of those documents is the highest level document is called the security target. The security target specifies all the threats that your product will counter. It will describe the product, all the interfaces it has, all the types of users, the type of administrating users, and it has to describe the threats that the environment poses and the security that it assumes in the environment.